Hey guys, Mr. Beeler here. Today we're going to talk about electrical. It's one of the harder subjects to understand in the automotive industry. A lot of guys struggle with it. So I'm going to try to keep it as simple as I can starting out, and we'll build upon it as we go. A lot of times with electrical, it's compared to water flow. I've got a piece of heater hose. We're not going to go outside with the garden hose today, it's a little cold out. But if you can imagine water flowing out of your garden hose, the water flowing, the flow of the water is equivalent to amperage. If you think of another way to remember amperage, you think of water flowing through a river, there's a current. They often refer to as amperage as current. The pressure of that water, also known as volts or our voltage, so as water's flowing out, we have flow, which is amperage, we have pressure, which is volts. If I restrict that flow, I put my thumb over the end of the hose, the flow goes down. We still have our pressure, our flow decreases. So resistance has an impact on flow. In electrical, our main measurements we can do are volts, amps, and ohms. Volts is the equivalent to pressure. If you think of water flowing, it's pressure. Our amperage is our currents, how many electrons are moving through that conductor. And our ohms is a resistance or a restriction in that circuit as far as preventing flow. In a complete circuit, there are three things we need in a complete circuit. We need a power supply, so a battery, and the battery has to have voltage. Voltage is a difference in pressure of electrons. The electrons always want to equal out. They want a positive and negative, they want to be equal. So we have a power supply, we attach a conductor, those electrons are going to flow through that conductor and try to equalize the pressure. We have conductors, which in the automotive world is usually wiring, and they'll use the chassis or the body of the car as a conductor. Oftentimes everything's grounded through the chassis. And then we have a load. The load does some kind of work for us. So load, it can be something as simple as a light bulb, it can be a blower motor, or it could be a starter solenoid or a fuel injector. Now, loads do work for us. So a bulb is going to create light, a little bit of heat for us. A motor is going to convert the electrical energy into the rotational force. A coil such as a injector or a starter solenoid is going to create electromagnetic force. It's going to move something by pulling with electromagnetic force. And there's other loads we're going to talk about as we go into, such as like heated seats, cooling fan motors, other items such as that. So in a electrical circuit, for a complete electrical circuit, we need a power supply, conductors to carry the volts to the component and back from the component, and a load. If we start talking in Ohm's Law, we're going to get just a little bit in Ohm's Law today, we'll get into it more later. Ohm's Law states that volts equal our amperage times our resistance. So just like we talked with the garden hose, if I restrict the end of the hose, amperage goes down. So my restriction went up, my amperage went down, volts still stayed the same. In the automotive world, we're going to talk DC volts mainly. DC and AC, so we've got DC is direct current, AC is alternating current. It has to do with how the electrons flow. In alternating current, the electrons just move back and forth in the conductor. DC, they keep going through the conductor until they reach the end. Some places will write Ohm's Law as E equals I times R. E meaning electromotive force or volts. I, sometimes guys like to think of it as intensity. Amperage is kind of intense. If you think of, if you go back to the water analogy of current flow, you think whitewater rapids. It's pretty intense. So amperage or current flow equals I for intensity times R, which is resistance. So again, as let's say resistance goes down, our amps are going to go up and our voltage is going to stay the same. So I will have current or further videos after this. I'm going to try to keep them kind of simple, kind of short for you guys. And we will get through electrical together online while we deal with coronavirus. I will see you next time.